Spherical robots may soon explore hidden caves on Saturn's moon Titan in search of subsurface oceans. This is Fascinating Frontiers, episode 164. An early-stage NASA grant supports development of spherical aerobots designed to navigate caves on Saturn's moon Titan. The concept draws from the Mars Ingenuity helicopter, but adapts for Titan's dense atmosphere and low gravity. The vehicles would explore subsurface voids potentially linked to liquid reservoirs. Engineers are evaluating materials that withstand cryogenic temperatures while maintaining buoyancy in nitrogen-rich air. A demo mission could test mobility and sampling in this extreme environment. Now we turn to the technology itself in more detail. NASA's early-stage grant for spherical aerobots targets cave systems on Titan that may connect to subsurface liquid reservoirs. The vehicles would use the moon's thick nitrogen atmosphere for lift and buoyancy while rolling or hopping across uneven terrain. Engineers are adapting lessons from the short-lived Ingenuity helicopter to Titan's colder, denser conditions. A successful demo could open access to environments shielded from surface radiation. What remains unknown is whether any of these caves contain the complex chemistry needed to support prebiotic processes. From one ambitious robotic explorer to another nation's race for untouched samples, we turn to Japan's upcoming mission to the moons of Mars. Japanese scientists are developing a sample return mission targeting Phobos and Deimos. The spacecraft aims to collect material that could reveal the moon's origins and early solar system conditions. A Chinese mission is also racing to return samples from the same moons. Success would provide the first direct samples from any Martian satellite. The Japanese effort includes precision landing systems designed for the low-gravity surfaces of the small bodies. While one team prepares to bring pieces of Martian satellites home, another observatory has already caught a fleeting glimpse of a magnetar's birth. The Einstein probe detected a rare X-ray flash tied to a supernova with unusual properties. The event points to the formation of a rapidly spinning, ultra-dense magnetar. A paper detailing the findings appeared in the Astrophysical Journal Letters on July 22nd. Multi-wavelength follow-up confirmed the connection between the flash and the remnant. The detection adds to evidence that some core collapse events leave behind highly magnetized neutron stars rather than black holes. From the violent death of a single star, we zoom out to how stars and planets shape each other over cosmic time. The International Astronomical Union Symposium 408 runs August 17 to 21 in Liege, Belgium. Sessions focus on how stellar activity and planetary evolution interact over time. Researchers will present new models linking star formation environments to the atmospheres and orbits of planets that form around them. The meeting is part of NASA's Exoplanet Exploration Program efforts to coordinate international observations. Follow-up papers from the symposium are expected later this year. The event brings together observers and theorists working on joint star-planet systems. Coordinated international science on distant systems also drives practical partnerships closer to home. A single molecular cloud can stretch across distances comparable to the width of North America, yet radio telescopes detect its chemistry from thousands of light-years away by tuning into faint emission lines. Imagine riding alongside a radio wave as it leaves a cold clump of gas. The wave carries the unique rotational signature of each molecule it encounters, turning the cloud into a vast, natural spectrometer. One surprising number stands out in recent maps. Complex organic molecules appear concentrated in regions only a few hundred astronomical units across, pockets small enough to fit inside our own solar system. These pockets act as chemical factories where simple ices on dust grains are broken apart and reassembled by gentle shocks and ultraviolet light. The process runs on timescales of hundreds of thousands of years, far slower than any laboratory reaction, yet fast enough to enrich material before the next generation of stars forms. We can watch the molecules light up in radio images, but nobody yet knows exactly why certain species survive the journey into planet-forming disks while others vanish. NASA has invited the Indian Space Research Organization to participate in its moon base program. The collaboration would focus on lunar exploration infrastructure and shared technology development. Details on specific roles for ISRO remain under discussion. The move builds on existing Artemis Accords partnerships between the two agencies. Indian contributions could include lander systems or habitat modules for sustained surface operations. Government partnerships set the stage for commercial players merging to deliver everyday connectivity from orbit. Link Global has completed its merger with Omnispace and rebranded as LVO Mobile. The new company gains globally coordinated S-band spectrum to expand direct-to-device satellite services. Services will move beyond basic messaging toward broader connectivity applications. The merger aims to strengthen commercial offerings in a competitive direct-to-device market. Coordinated spectrum access should improve coverage consistency across multiple orbital planes. While companies consolidate spectrum, agencies are studying how to clear aging satellites from those same orbital lanes. The U.S. Space Force and other defense agencies have selected Firefly, D-Orbit USA, and Catalyst for satellite disposal studies. The companies will demonstrate how commercial systems could capture and remove aging spacecraft. The work addresses growing concerns about orbital debris in key altitude bands. Each firm brings distinct capture mechanisms under evaluation for different satellite classes. Successful demonstrations could lead to operational debris removal services within the next several years. Today's astronomy picture of the day shows a solar eclipse with a striking golden corona. The image captures the sun's outer atmosphere during totality. NASA's APOD archive continues its daily release of professionally explained astronomical photographs. The corona appears in vivid color due to specific wavelength filtering during post-processing. Viewers can access the full archive for historical eclipse imagery dating back decades. NASA planes are collecting data on smoke lofted high by towering smoke-infused pyrocumulonimbus clouds. These fire-driven clouds can inject particles into the upper troposphere and lower stratosphere. The campaign targets one of the most intense examples currently active over Utah. Measurements will improve models of how wildfire smoke affects atmospheric chemistry and climate. Instruments aboard the aircraft record particle size distributions and chemical composition at multiple altitudes. On August 16, 1898, Delisle Stewart captured photographic plates that later revealed Saturn's moon Phoebe. William Pickering announced the discovery in March 1899. Phoebe became the first moon found on photographs rather than through direct observation. It was also the first target visited by the Cassini spacecraft more than a century later. The moon's irregular orbit continues to inform models of captured objects in the outer solar system. Artemis II pilot Reed Wiseman thanked NASA for permission to fly Orion manually during the mission. The comment came during an August 3 event at Red Rocks Amphitheater attended by over 8,000 people. Crew members highlighted the trust placed in them by the agency and contractors. The flight remains scheduled as the first crewed test of the Orion spacecraft. Manual control demonstrations are intended to validate backup procedures for future lunar missions. China has published a detailed map of the moon's far side that includes new chronological data and a homegrown cartographic standard. The map supports future landing site selection and resource assessment. Officials describe the effort as extending beyond technological demonstration to shape international lunar mapping practices. The dataset incorporates imagery from recent orbiters and surface missions. Updated chronology refines the timeline of impact events on the previously less studied hemisphere. Next time, we will be watching for further updates on the Japanese sample return mission timeline and any new coordination with the competing Chinese effort. That's Fascinating Frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at NERA Network. Links in the show notes. This show comes to you from the NERA Network. If you want another sharp daily briefing, Offshore North has you covered. Offshore ocean racing explained every Monday with a Canadian angle. All our shows are free at neranetwork.com. Prefer reading? Today's full write-up, sources, and transcript are on the episode blog at neranetwork.com. Same briefing, readable format. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
drifting softly through